Yeah. Uh, Topic. I like to know how many of you are familiar with the terms or machine learning terms, or anybody is new to it, so that I can focus based on that. You can reply in the chat. If anybody is new, okay. So just I carry over the session with. Okay. Before I start the session, I'd like to introduce myself. Myself, Dr. R. Manjula Devi, Professor, Computer Science and Engineering Department, as well as I'm heading the IQAC cell in KPR, Institute of Engineering and Technology, Coimbatore. Okay. So I like to that in today's world, data plays a very major role. Okay. So what is mean by data? Okay, it is not a object or anything else. It is a value. Okay, so each and everyone know we are receiving approximately 1.7 MB of data. Okay, as per the survey of 2023 20. Okay, so each and every second we are receiving 1.7 MB of data. Okay, so what is the data plays a very important role means if you take any field, data is very important. It plays a very vital role in all fields, not only in the AML or artificial intelligence. It plays a major role in it. You take meteorological data is going to present it. Okay, for either about the weather forecasting. If it is financial, again the data. Again, it will takes any if you are going to take a number of fuels consumed by the vehicle. Again, the data plays a very important role. If you talk data plays a very important role. So here the data is speaking at every each and every place in the world. So without data, nothing is conveyed. Okay. Why data? Is it necessary? Yes, I already said data is very essential. It speaks. Okay, data only speaks everything. It to get the information. Okay, so if you take it, what is the temperature of today's temperature? Say it is the data. What does it confirm? You can say whether it is a hot or cold. Okay, so that data gives you information. Without data, what is the degree of today's temperature means you can't say anything else. So I have to specify your temperature in terms of data. That data will confer gives your information. So without data, we can't give information. Data, we are taking the information. So from the information, you can able to answer it. If I ask, okay, whether you how would I say if my temperature is less than 20 information. So using that information only, I can able to tell the answer to the person who is asking question to me. So then, what is the purpose of answer then? So based on the answer, I can able to take the decision. So if you're going to plan for a tour or anywhere, okay. So based on the weather condition, you will arrange the cloth based on that. If it is very hot, you will arrange the plan based on that. So based on the answer, I can able to decision the goal. So I can able to reach the goal. So you can say the data is nothing else. It is a vital role at each and everywhere. Okay, okay. So we already said, we all know that by the we are having a natural intelligence. So what does the natural intelligence mean? So if you take a child, okay, so a newborn baby doesn't know anything about this. Her brain is very blank. Okay, so what you will do? How the when the they doesn't know anything else. Even if you take any, if you're going to teach them any new thing, you have to teach that particular. It is a newborn baby, you have to teach them at least for 10 times. Then only when it is comes to 11th time, he or she can able to recognize the thing. Example, if you take alphabet, by taking a single time, the child will not learn the alphabet. Okay, at least 10 to 20 times you have to teach them it is B or it is A and it is C. Same thing. Okay, the child can able to recognize it in any form. Even if you change the shape of the he or she can able to recognize it based on the knowledge that has been gathered during the training. So this is the natural intelligence that we have it as a human being. Okay. So what is it? What does mean by learning? Nothing but you're acquiring the knowledge. Okay, we are not doing any information, or I already said from the data you will get the information from the nothing else, acquiring the knowledge or skill. So based on the knowledge and the skill, you can able to answer the any data or anything in future. Knowledge will be applied in the future. So what is mean by knowledge? Nothing but I already said it is a fact or information. So where will get the fact or information from the data? Okay. So can it time? No, it has to be acquired only through the experience. Okay, so already said that the child cannot learn the alphabet in a single time. They has to undergo many times. Okay, we have to teach them the same alphabet again and again till the child learns. Okay, when it learns, we don't need to teach it. Same thing. It is an experience. Okay, so I already said data. From the data, you are getting the information. From the information, you are get from the information that knowledge will be applied in the forthcoming days. So, what is the difference between that your data, your learning? Okay, you are getting the information from the data and you are storing it in your brain. What is the knowledge? The array is going out of your brain. That means whatever the learning, whatever the knowledge that you have gathered during the learning, that will be applied in the new forthcoming days. So that is the difference between learning and the knowledge. The knowledge that you have gathered, you learning. We all know that learning, sure, it will improve the performance from the experience. So this terms plays a very important role in your machine learning. The learning will improve performance from experience. Performance is a major role in machine learning. These are everything is coming under what is mean by machine learning. Machine learning is nothing but machine plus learning. Learning is nothing but I already said what is the purpose of learning and how we are learning it. So the same thing, natural intelligence, the learning is done Intelligence of a human brain plays a major role in natural intelligence. Okay, here machine learning, the same learning concept that you are making the machine to do it. That is, machine learning is nothing but machine plus learning. We are making the machine to imitate and adapt like a human. Human, the machine to act like a human. Okay, we all know it. What is the purpose of machine learning? So why we are going for machine learning? When you say it is 2 plus 2, what is it 2 plus 2? Yeah, 4. 2 plus 3 plus 4 plus 7 plus 8 plus 9 plus. I need the answer immediately. Plus 4 plus 5 plus 7 plus 10 plus. If it is a random number, is it possible for the human to predict the answer within the same second, the time that is taken to perform 2 plus 2? No, it will vary as a human, is it? But the computer can do it. Okay, the machine, that means the machine can perform it. So this unique nature of the machine makes to think that is the core, that is the strong point. Okay, this is the strong feature wherever, because whenever psychologically the human cannot improve the computation speed. Okay, the but the machine can do it within the seconds or within a nanosecond learning. So that is one of the points here, major points here. Increase in data. Are the points where we have to think. Okay, so first, why we are going for machine learning means increase in data generation. We all know that today's environment, the data is getting data is getting increased. Okay, so we are not quick, we can't make the human to do computation. So we are going for machine learning. Second, improve the decision making. Same thing, when you compare to the human analysis, machine analysis is very fast. Okay, so what is the meaning of it? 0 0 0 1 1. Can you able to, this is my output. Okay, 0 0 1. So the third part is my output. What you are going to conclude it, this one, from this, what conclusion you can take, and this is my output. From this, what you are concluding it, any idea that you can able to analysis from this data, please. Those who are like to learn from the core, please understand this answer for this question. 0 1 0 also 0, 1 1 is 1. Okay, so what does it mean? So I can able to say, when the input, okay, the output is 1. If any one of the input is 0, I can say my output is 0. So this is a simple data where a human can able to make a decision. Suppose if you assume that I am having 100 input features, number of input is 100, I am having 1000 samples in it. Is it possible for you to generate the pattern here for the given Okay, it is not at all possible over here. So that is the decision making by machine will improve it. Okay. Second, now I can say the output is zero. If both the input are one, my output is one. So this is the pattern that is lies behind this data. Okay. But when come to this, okay, it is not possible for human to predict the pattern. Okay. So cover extract the pattern from the given data, and also when you go into the solve the complex problem, you can do it. Machine learning means it is nothing but a study of algorithm. Okay, so study of algorithm. Okay, what is the purpose of it? What is the need of it? Okay, in order to improve the performance. So these key terms is very. P is nothing but improve performance, task, and experience. Okay, so that is this nothing but well-defined learning task performance. For what? Whenever you are going to do some task, okay, what is our objective will be just to improve the performance are always our objective. Okay, so in order to perform any task, that performance metrics outcome of that particular task should be improved. So how you will perform the task? So based on the previous experience, if you are not will be great unless you doesn't know if unless you know knowledge about that particular task. Okay, if you have a knowledge, you can able to perform that particular task well. If you doesn't know the knowledge, sure you are not able to perform the task. Now, what is the difference between traditional program and the ML? That is your input that we are providing it. Second is your program to execute it. Just we will type the program. Okay, so for executing the program, you will be giving the input. Okay, so the program will receive the input from the users. So the program will get executed in the computers, and the program will produce the output. So this is the traditional programming that we are adapting it. So what about the ML? To the computer. So based on the input and the output, the program will be developed. Program is nothing but model, ML model. This particular input, this is the output that you will provided it. You have to discover the pattern between the input and the output. So we will know that output is derived from the input. Okay. So what function that what input so that your output will be reached. Okay, you will be applying the mathematical model to the particular input. Okay, output. So the model is nothing but deriving this f. F is nothing but mathematical model. So that is I already said model. The next, all data is cooked. So I already said data and we'll be providing it. So this is the raw data. Okay, it will not have any format. Segregate the data in the features. That means you have to present your data into the machine learning in the 2D format. Just you have to analyze what are the features you have, and this is for each and every features I have to collect the samples. So this is 2D features. I will be collecting it, and this will be given into the algorithms for training. So already said the data will be collected from different sources. Okay, so that is your raw data. So that raw data will be cleaned and transformed into the features. Okay, so based on our expectation, your data will be transformed. So that feature will be given as the training, and from the training you will be creating the model. So that model will be applied in feature for prediction. Whatever the model that you have created during training, which will be used in features for prediction or classification process, based on your application it will be used. So this is the ML model data. So you will be going for training. Once the training is over, a model will be built. So from this model you will be predicting the outcome. So these are the basics of machine learning. So when you gives the glimpse of the machine learning, I already said from the nothing but the data plays a major role in each and every field. So from the data, your information will be extracted. So from the information, you will be extracting the knowledge. So whatever the knowledge that you have gathered, that will be applied in future for further decision. Okay, so that is your knowledge. So whatever the knowledge that you have gathered, that you will be applying for in future for forthcoming prediction. If you can able to do the forthcoming process in a correct manner, means so the knowledge that you have gathered is okay. If it is not, means you have the whatever the knowledge that you have gathered is not sufficient, again you have to go for uh, more learning from it. Okay, so that is the meaning of the machine learning. So why we are going for machine learning means, as far the computation is concerned, we all know that the computer can able to compute very fast than the human. Okay, so that makes the human being to think to go for the machine learning. Okay, so that you can able to improve the decision making, and you can able to whatever the pattern that cannot be discovered by the human, but the computer can do it. So these are the things that the computer can do it. So this is the difference between natural intelligence and the machine learning. Then these are the glimpse of your machine learning. When it comes to the types of machine learning, there are four types. First one is supervised learning. Second one is unsupervised learning. Third one is semi-supervised learning. Fourth one is reinforcement learning. Okay. So what is mean by, first we'll discuss about supervised learning. What is mean by supervised learning? From the name itself, I can say it is a supervised. We are having supervisor for both project, UG project students, are PG project students, and it's a PhD, wherever it is, we are giving the name supervisor. So what is the meaning of supervisor? Okay, we all know that students doesn't know the basic. Okay, so the supervisor will guide the students what to do and what should not do. Okay, even if he or she does anything wrong, we will say that this is the wrong and you should not do this, and this is the way that you have to do it. So just some guidance will be provided by the supervisor. 1 minute. And thank you. Sorry for the interruption. Okay. So when it comes to the supervised learning, nothing but the learning with some guidance. So what is how you are going to represent in real time? Guidance means any person is giving input while you are going for implementation. No, not like that. From the input that you are providing to the computers, so there your data based from the data you can categorize into it is a supervised and supervised learning. So what categories you are giving it? So from the input data set. Okay, so if you are providing your data along with the output, okay, so I already said you are giving input as well as the output for the machine learning. Is it? So if the input along with the input, if you are providing the output means I can say it is an supervised learning. That means that whatever the data set that you are going to give as an input to the program, if that data set contains your output, means I can say it is a supervised learning. If the particular data set doesn't have an output, it contains only the input, means I can say it is an unsupervised learning. That means it has to learn by itself based on the input. What is semi-supervised means half of the data will have input, output, and half will not have the output. So that is the semi-supervised. Reinforcement. From the name itself, you can say it is reinforcement. That means you are providing the output of the previous iteration as an input to the next iteration. That is enforcement, enforcement, giving the input based on the previous output, you will be feed as an input for the next iteration. to see it. So for this, I'm going to show the live output ECA repository for these two types of data set. Is very, very essential. So from the ECA repository, I'm clicking on it. So this is the popular data sets are there, every data sets. So each and everything will have the classification here. Here summary will have classification and regression, and this is the exclusive regression type. So this is the categories. Okay. So I will give the live example how your uh, regression model will be. Now I'll go for hard disease data set. So download data set. I'm going for hard disease. My data set has been downloaded here. So here, this is my data sets. So we will look into it. 13 features are there. Okay, so you have 13 values in each and every row, and 303 instant. If you count it, the number of instant that you have is 303. But this is another data. We have to extract the actual data from here. This is the Hungarian. Just will go for another direct download of it. Really, I will download this one. The same data set I have downloaded. So multivariant guide data. So here, when you take it, subject, condition, replica, like categorical, join, time. So these are the inputs. Okay, subject is a categorical data, condition is categorical. So features, role is features means. So these three are the input data, and the last one is ankle, is a continuous value. So my output is continuous. So I can say this is a regression type. Just I'll open it and give it. Just a quick time to open it. So, so this is my output label. Okay, and the remaining these four are your input labels. So based on this input, your output will be predicted. If you take any values in this output column, none of the value will be repeated. Based on the input combination, okay, my output will be changed. So it is the continuous. Okay, so it is a real value. So I can say this problem is a regression problem. Okay, so if it is a classical classification means my output will be in the form of categorical one. So the output is yes or no, that type will be coming off. Shall we go for any classification problem for your satisfaction? This is download home page. Real waste. So real waste is an input image. So just you look into it. If you get anything, you can able to get it. Classification means your output class label will be your categorical one. Table, column. So I can able to get this in the CSV file. So if you take it, so here this last column is an iris itasa column, versicolor, virginica. So three types of there. Okay. So this is my classification problem. So my output is category one of the either citaso or it belongs to versicolor or it is virginica. So it can belongs one of these two types. So it is a categorical value. Now I can say this type of problem is a classification problem. Is that understand what is the difference between your regression and classification? So what is mean by supervised learning? Under supervised learning there are two categories are there. Regression is there and the classification is there. If it is regression means output value will be a continuous value. If it is classification means it is a categorical value. Do you have any doubt till now? Yes, I understood that you understood it. So again, the classification means my output column will be your categorical value. If it is categorical means then I can say it is a classification problem. Now when you look into it, before you going for regression, some basic terms you should be very clear with this. What is mean by linear and non-linear? Anybody? Any idea with respect to linear and non-linear? What is mean by linear and what is mean by non-linear? So these two pictures represent the first two pictures represents the linear and third one represents the non-linear relationship. What is mean by that? Any idea? Linear and non-linear? Any idea? Linear and non-linear? Okay, I'll go ahead. Linear means from the name itself I can say when the x value is getting increased. Okay, so what my y value is, it is also gradually it is getting increased. Here as for the first figure, when the x value is getting increased, the y value is also getting increased. This is first case. Second case, when the x value is getting increased, my what about the condition of y value? It is getting decreased. So this is the relation, linear relationship. When the value getting increased, the value of y is also increased means, or if the value of x is increased, the value of y is getting decreased gradually means. So here there is a linear relation. Then I can say it is a linear relationship. So here I can't say it. If the x value is getting increased, I can't say that my y value is getting increased gradually. In some stages, the y can be a same or anything else. So same thing. Then if I can't predict in the form of it means I can say it is a non-linear one. Okay. So if again the first one is what is the difference between linear and non-linear? We have gone through it. Next one is what is the difference between independent variable and the dependent variable? Independent means, so when you say variable, what that variable will hold. So when you take a variable, it is used to hold a value. Everyone knows, when you take a variable, the variable is used to hold a value. Okay. Now, independent variable and dependent variable means when you are going to store a value for it means If that value is depends upon another value means variable means I can say that it is an dependent variable. Independent value variable means if the value of the particular variable doesn't depends upon that any other variable value means I can say that it is an independent. If it doesn't dependent means then I can say it is an independent. If it is dependent means it depends. So here this is a real time example for it, independent variable and the dependent variable. Okay, now I'll go with the PPT so that you can clearly view the pictures. Now, if you say is an independent variable mean the val is not dependent. Okay, so here the variable that is getting changed. Okay, the amount of water. Okay, so it doesn't depends upon anything else. And now if you take the plant, okay, so if you take with the respect to the plant, it is a different variable. What is the different variable means? Size of the plant, number of leaving or date. So if you want to measure this variable means it will depends upon this independent variable, amount of water. Here amount of water is an independent variable, I am saying it. Okay, so whereas the dependent variable is nothing but size of the plant, number of leaves and living or dead. If you pour more water also, the size of the plant will not be moderate. Okay, it will not be an efficient one. Size of the plant, number of leaves, living or dead. If you doesn't pour any water also, it is a plain. If you pour middle water, so here this is, we are pouring the water in a medium way. So I can the plant, the particular plant is grows in a healthy manner. If you are pouring more water means the plant will die. If you pour less water means the plant will not die, but it will grow little bit slower compared to this plant. So that is so the plant growth is depends upon this amount of water. That means this variable depends upon the independent variable. Okay, the independent variable means the value for the particular variable will not depends upon any other one. Okay, next comes to the linear regression model. I already said regression is nothing but your output label will be a continuous value. It is a supervised machine learning model, but in the case that linear regression model means, okay, the output label will be a continuous. Now, what is our role of the linear regression model? Now, if you take it, this your input data in the data set, you will be presenting your. So in the X column, whenever you take any variable, you will be plotting your input in the X variable and corresponding where out y carries your output value. So this is your input and this is your output. So I'll plot the point with the graph. Okay. So for this value and this is my output. For this is the value and this is my output. So based on the data points which is available in the data set, I have plotted all the points. So what is our goal? What is our linear regression model means? Okay, it should not get a model like this. So whenever you're going for it, your model should not be like this. So here, I should not get the lines accurately. Okay, if that is the case, okay, I can't predict the datas in a. So when you say this, I should not derive a line that approximately matches with this. If you are deriving the line, if you get the mathematical for this line means I can say it is overfitting. Okay, that means I'm deriving the mathematical model what with specific to the particular data set. If that is the case, sure your system will be failed. So what is our objective should be means. Okay, it should not be a overfit and it should not be a underfit. It should be a generalized model. Generalized means whatever it is applicable in future also, it should be predicted it. Okay, if it is overfit means, what does that mean? Means you are designed the mathematical model only with respect to the particular data set. If any data set which is not available in the data, not available in the training data that you are going for training under this situation means, okay, if any new data sets comes, it cannot able to handle it if it is an underfit, yeah, overfit. Now what we are going to derive it means, so here check with this, if check with this line, visit it overlaps it any data set, no, but you have to derive a, such a line that all the data which is nearer to it. So how you have to design the model means, it should find the best fit linear line, not exact fit. Exact means it will be an overfit. Okay, so between the independent variable and the dependent variable. So that is, if you can, that line will be a linear line. When the x value is getting increased, it is also getting increased means there is a linear line. I can say it is a linear regression line. If I'm able to define a linear line means, then I can say that model is a linear regression model. Okay, so under this regression model, it consists of two types. One is simple regression model, and the second one is multiple regression model. What is the difference between these two? Just a simple. Now, we all know that how will you represent the line? Whenever a new line comes, the mathematical model for this line will be y equal to mx plus b. Okay, so what is, yeah, x represents? It is the x coordinate. What is it y coordinates? It is the y coordinate. What is this m represents? It is the slope. What is b represents? It is the y intercept. What does mean by y intercept? So now when I draw a line, so this is my x axis and this is my x axis and this is my y axis and this is my line, actual line. Okay, so this exponent represents x and the corresponding y represents y. Then what is b means? When you extend this line, for example, when you, this is my actual line. Okay, when you extend this line, you know somewhere this getting interrupted. This y value is your b interrupt. Somewhere when you extend the line, when you extend the actual line means, okay, some point it will be interrupted with y axis, that is your b intercept. Okay, b value, that is y intercept value is your b. What is it b means? So we all know that x is getting, and when the value of x is getting increased, the y value is getting increased. We doesn't know how much percentage of y is getting increased, so that increased level has to be identified, that is your slope. How far your line is inclined, that is your slope. Basically we will, so when you climb a terrace, or when you climb a steps, or when you climb any mountain, we saw it is very sloping means the degree is getting higher. So when you say it is very comfortable to walk because it is not very slopy, so that means incline of the step, incline of the mountain, incline of the terrace. So how far the slope is getting inclined. Okay, when the slope is increased, so automatically the incline will get increased. So here, so that will be your m. Okay, so this is the basic mathematical explanation for a uh, particular line. Okay, so base, this is the basic for the regression model. Not only the basic, it is the basic model for everything. So already I have defined y equal to f of x, output equal to f of input. F is a mathematical model. So that mathematical model we are going to define it. Now here, as per this linear regression model, my mathematical model is a line. That is a simple line, linear line. So this linear line, mathematically I can represent it as y is equal to mx plus b. M is a slope and x is an coordinate and b is the intercept. So that is the concept. So here simple linear regression means y equal to b dot plus b1x. That means y equal to b plus mx. So if number of variable here is only one variable means I can say it is an simple linear regression model. Only one independent variable is present means then I can say it is an simple regression model. Okay, now what is my goal field means I have to find a regression line. So this is my regression line, and this black dot represents my actual data, and this red line represents the difference between my line and the actual data value. So that represents the error. So that means this is my line that I have found out, but this is my actual value. Okay, this is my predicted value, and this is my actual. So how far it is getting deviated is a error terms. Okay, so it also called as residual. Okay, so this is the black dot represents the data points, and B represents the interrupt. So here black dot represents the data points, actual value, and represents the intercept and slope of the x value, and the blue line represents the best regression line that we have derived from the data. Okay, the blue line is the best fit line predicted by the model, that is the predicted value. Okay, and black dot is their actual value. So now how far that you have deviated from the actual value, so that is the error. So you can say that the vertical line between the data points and the regression line, I can say it is an error or residual. Okay, so here what is our objective, whether that residual value should get increased or decreased. Okay, our objective, the error value should get decreased. You have to give a training such a way that error value, that means data point should be moved towards your regression line. Okay, you have to train such a way that the data points should be moved towards that particular line. The less the error, more the performance it is. So that is the logic behind it. Okay, so that is the simple regression model. So in this, any doubt so far? What is the purpose of linear regression? Linear regression model. Any clarification? Chandra sir, thank you, sir. Shall I proceed, sir? Okay, sir. Next comes to the least square method. What is mean by least? The name itself is the least square. Square, you are going to perform some square. That square value should be a minimal one. That is the meaning of least square. It means I already said this is my observed value and this is my actual value. You are finding the difference between these two. That is the error that we are saying it. The difference of the error, you will be squaring it. That square value should be as minimal as possible. This is the least square method process of finding a regression line that best fitted line of the data set or the particular data set, it should be a best line. That means the method requires sum of the squares. I already said you are performing the square, so that squared value should be a minimum 1. That is the meaning of it. Reducing the sum of the square of the residual part, that is your error part. Next comes to the multiple linear regression. I already said simple linear regression means number of input value will be a 1. Here number of independent variable input are nothing but independent variable. Here the number of independent variable is more than 1. If you're having more than one independent variable, it is a multiple linear model. Same way here it is B0 is intercept and B1, B2, B3 is the corresponding coefficient. Okay, and Y is the independent variable. So that is your multiple linear regression model. Now we'll go ahead with an example. Now, as for if you're going to predict the price of the computer means, okay, so based on the RAM capacity, the cost will get varied. If it is 2 GB means it is $12. If it is 4 GB means it is a $16. If it is 8 GB means it is 28 model. If it is 16 GB means it is 62 model. So RAM is an independent variable and cost is a dependent variable. Why it is a dependent variable means the cost is purely depends upon the capacity of the RAM. Whereas the RAM capacity doesn't want to depends upon any variable. So the cost depends upon the capacity of the RAM. Now, if you take this, I have plotted this. So what is the first data set? It is a 2 GB. So the 2 GB RAM. So here RAM capacity is x-axis. My cost will be your y-axis. So now I am plotting it 2 GB. So 2 GB, what is the actual value? 12. So I have plotted here. Next 4 GB, the actual value is 16. So it has been plotted here. Then 8 GB, it is 28. It has been plotted here. Then 16 GB, it has been plotted as 62. So here I have designed a regress line in such a way that it is best fit for all the data point. Okay, I already said it should not be a curve which covers all the data. It is then overfit. If it is moved away from all the data set, it is an underfit. So it should be a line which is close to all the data set in such a way that the actual error value between each and every data sets and the line should get reduced. So if you look into it, so this error value will is minimum, and this is error set is also minimum, and this is also somewhere minimal, and this is the only data set which is little bit away from the line. So when you take the average, so totally the error will be get reduced. So this is the way you have to find a line such a way that the total error value should get reduced. So, and these are the evaluation metrics that has been considered for it. It is a mean squared error. Okay, nothing but what is the meaning of it means y is your actual output and this is my predicted output. You have to sum these two, see, subtract these two. So whatever the value that you are getting it, you have to square it. Okay, since it is a supervised learning, we all know you'll have the y value in your data sets itself. Okay, you'll have your output in the data sets itself. So the y represents the value which is available in the data set, and this is your output that is produced by the network for the particular input. We have to subtract the 2. Okay, once you get this 2, you will be squaring it. Once you squared it, you have to, because this is only for a single sample. Okay, so you're having multiple sample based on your data set. Your data set, how many? If you're having 1,000 samples in the data set, means you have to get the comparative value for thousands, and you have to add it up. Okay, when you add it and when you divide by 1,000 means you will get the average value, that is mean square error. Error means difference between y and y is a error. Square means you are squaring it. Mean means you are adding all the error value of the 1,000 samples and you are dividing it. So that is mean. So mean square error. Whenever you are going for this, you have to go in the reverse. just finding the error first. That error value you are squaring it off, and then you are calculating the mean value of that. That is called as mean square error. Next comes to the root mean square. From the name itself, you are finding the error. From the error, you are going to square it, and then that squared value you are finding the mean value. So that whatever the mean value that you are going to get, you are taking the square root of it. So the square root of it, that is r squared in adjacent to r squared. So many performance metrics are there, evolution metrics. So this is the one which will be used frequently for your linear regression model. Any doubt till now? Shall we move on to this? Yes, shall we move on to the linear or regression evolution metrics? Okay. Now we'll move into the Bayesian linear regression. We all know that it is a Bayesian knowledge. What does mean by Bayesian? Any know in Bayes theorem? Bayes theorem, probability of A of B is, so here probability of B will be coming in the denominator. So probability of B with respect to A into probability of A divided by probability of P. This is the Bayes theorem. So what is the Bayes theorem represents means? So it is going for whenever you are going to predict the probability means, you should know the probability you should need it, and also with the prior knowledge of that one. So prior priority, posterior priorities, everything is there. Okay, so here this is my Bayes theorem. You are applying this concept to the linear regression concept. They already said employs prior knowledge about the data. If you have prior knowledge about the data, show that you will learn more. When you learn more, automatically your knowledge gets improved. When the knowledge is getting improved, automatically the process, the performance for the particular task will get increased. When the performance get increased, automatically the prediction will be accurate. That is, if you are having knowledge, sure your learning get improved. When the learning will get improved means automatically the prediction will get improved. This is the knowledge. Okay, so thus you are using this prior knowledge is the major concern with the not concern, is a major strength of the Bayesian theorem. This knowledge is used to estimate the parameters of the linear regression model. That's all. Nothing else is there. Whatever the linear regression model that you have done, whatever has been discussed so far, the same concept. The concept is didn't vary it. Okay, your objective is to find a line. That line should be best fit. Okay, that best fit line should be suitable, and it has been derived based on the Bayes algorithm. That is a prior knowledge. So that is the concept of Bayesian linear regression. Next comes to the gradient descent. What is the meaning of descent? Descent is nothing but decreasing. Descent means it is getting decreased, or it is getting that affected, that the outcome. Okay, the impact is getting reduced. That is the should be getting calculated way. So for example, so the gradient descent technique means this is my weight and this is my cost. Okay, so this is my weight and this is my cost. So here, what is our objective means, as far the cost is concerned, our objective should be as minimum as minimum as possible. If it is concerned with the profit, my profit should be as maximum as possible. So based on your objective function, your maximum or minimum value will be differ. If it is cost, it should be a minimum. If it is a profit, it should be a maximum. So whatever it may be, it is applicable for it. So this is my target goal, where this is the where I have to reach. Okay, So this is the function of the whatever the function that I have defined for this cos mathematical function that I defined for the cos is this is the curve. Okay, my how to reach here, but now at present I am here. Okay, so I have to move towards this goal. Okay, so slow by little I have to increase. For example, it is similar to coming down from the hills. Okay, while you are coming down, okay, you have to step your leg little by little. Then only I can able to move towards my target. If I keep the leg here and there means your you not able to get a grip, you will not reach the goal. Okay, same way here. Okay, whenever it is dissonant, so here if you draw a line, it is the slope line gradient. Okay, my step of decrease should be little by based on the slope function. I will be moving my values towards the goal. So this is my initial value and this is my incremental step at each, and ensure that the incremental step the value is getting decreased. So here, when you look into the size of the air itself, you know it. Here, this is the size of the air is large. Large. When compared to this, and this is little bit when compared to this, this is little bit less. So the value towards the target. So this is called as gradient. Okay, the Sorry, some network issue. Sorry for the interruption. Since my slide is sharing the problem with my laptop network. Just I'll join with you in mobile, then I'll come to the there. So when it comes to the next topic, it is your stochastic gradient descent, and then I'll go with the logistic regression. So what is the meaning of logistic regression? We already discussed about linear regression. Now, what is the difference between logistic regression and the linear regression? I already explained about differentiation, classification, and regression. Okay, now we'll discuss about the importance of logistic regression. The linear regression is used to solve the regression problem. Okay, whereas the logistical regression problem is used to solve the classification problem. It has been adapted for solving the classification problem. Okay, so what makes these two difference? Here, the way that acts a function, that means mathematical function that we are defined it. Here, the mathematical function is a linear model. It will be a linear model. Whereas the logistical regression, it is a non-linear model here. So that is the difference between linear regression and the non-linear regression. Now, when it comes to the model will be your this one logistical regression. My function will be your uh, sinusoidal wave, mathematical wave. A curve, small curve will be here, will come like this. So that is the difference between simple that means linear regression and the non-linear regression. Now, what is the classification problem? I already discussed classification problem. Classification problem means my output label will be your discrete categorical way. So that is the difference between linear regression and the non-linear so based on that outpair. So that is one second. Some error is there.